Imagine someone drops you into the middle of a city expecting you to do a job. Everything you need is somewhere in the city. Wouldn't you wish you had a map? Hey everybody, I'm Rached and I'm an engineer at Fabrix.ai. Last time we talked about the universal tooling and connectivity engine, how we let agents connect to any system in the enterprise and make tools share data directly rather than pushing through the LLM. I ended with a question. Even if your agent can connect to any system in the enterprise, how does it know which ones are relevant to the task it's trying to accomplish? That's what this episode is about. Think about what happens when an agent gets a query in a large enterprise environment. Query? Do I say that weird? There might be dozens of data sources available to it. Databases, monitoring systems, ticketing platforms, CMDBs, network devices. Oftentimes, people just give the agent a list of all those places and let it figure it out, or they count on the fact that the agent can see all the tools and it's just going to guess which tool is going to get it the data that it needs. But that's slow, it's expensive, and it doesn't scale. Think about dropping into that city and just having to hunt for everything you're going to need to do the job that you need to do. It's an absolute waste of time, and oftentimes agents do it over and over and over again every time they get a new request. We actually ran into this with one of our biggest customers. I made a whole video about this that you can probably find in a link below. But briefly, they had previously contracted with another company to help develop some agents for them. And those agents were given access to a bunch of tools. Now, not only did the agent builder have trouble integrating with all their systems, but once they did, they found that the agent would get lost. It had so many choices of where to look and had no idea which data sources were going to be providing the pertinent information for the different tasks that it was asked to complete. Now, the way we solved it was by giving the agent a map, not a static programmed map. This is an important distinction. A lot of people reach for what I'd call an as-designed map, a knowledge graph that someone built by hand describing how everything is laid out. But one of the problems is that enterprises rarely look exactly the way that they were designed to be. They evolve, they're organic, they're living organizations, and data moves around and systems get upgraded, interfaces get developed. It's a moving target. The as-designed map and the as-built reality can be pretty different from each other. And an agent navigating by the wrong map can be worse than an agent with no map at all. What you need is a live map, a map that represents the environment as it exists right now. At Fabrix, we call the process of building that map Agentic Data Federation because we leverage agents for this. Specialist agents go out to each data source, for example, vCenter, Splunk, ServiceNow, your CMDB, your network devices, and to discover, sample, extract metadata, and profile the data. Then a cross-source correlation agent will come in to do the hard work of figuring out how things relate across sources. That VM name in vCenter and the host name in Splunk, it's the same entity, and the Ontology knows that. So honestly, building those correlations across different information domains is not an easy problem. It's a hard problem. Fortunately, it's a problem that Fabrix is very, very familiar with because we've been doing cross-domain correlation for a long time. We turned that expertise towards the project of developing a comprehensive enterprise ontology, where the agents discover the data sources, discover the schemas and the metadata, and our correlation engine is able to stitch these things together into one cohesive whole. Most platforms completely skip this part because it's actually pretty hard. Or they substitute a static knowledge graph, or sometimes even worse, they'll just stuff all of this information into the agent system prompt or into the instructions. That's a classic example of something that works at the demo and then fails later on in production. So the result of this process, the result of Agentic Data Federation, is what we call the ontology layer. It is a graph-based map of the enterprise data and software landscape. What data sources exist, what entities and attributes they contain, how they relate to each other, what functions you can perform on top of them. Once you have that, using it's almost obvious. When an agent receives a query, it checks the ontology for relevant entities. It identifies key relationships, creates a traversal plan, and goes to work. It's not exploring, it's navigating. The difference in convergence speed is significant. And the ontology doesn't sit in the execution path. It's not middleware that every request has to go through. It gets consulted at the time that the agent needs to make a decision or at the time that the agent needs to make a plan. As sources evolve, the ontology gets updated, and every agent benefits automatically. You don't have to edit your system prompts. You don't have to go into your graph database and tweak things manually. Agentic Data Federation keeps things up to speed and up to snuff constantly. We think that's pretty awesome. And when an agent really has to do a big job across a wide array of data sources and interact with a lot of tools, we see the ontology as making a dramatic difference in the success rate that the agent is able to achieve. But all these architectural tricks I've been talking to you about are not the only things you need to make enterprise agents awesome. Next time, we're going to shift gears a little bit. We've been talking a lot about how to make agents capable, but next we're going to talk about what it takes to make them safe to run in production. Observability, cost control, guardrails, human in the loop, because a capable agent you can't see or control is not ready. I hope you'll join me for the next one.